Okay, it is live now.
Okay. Hello, students. Good afternoon. Welcome to the Hangout of compilers. This is our last Hangout because we are going to start our finals tomorrow. So, hope all of you are doing well. And the semester is behind us. So, I hope everything went well. Um, the TAs have worked hard and returned your homeworks. So, all the stuff that you need to have for preparing for exam should be with you. I hope you have followed our suggestions of reading all the things from the book chapters, trying some problems similar to the homeworks from the back of the book, and also understood the concepts by looking at the algorithms and so on. And you're all ready for the finals. Did the onboarding. Some of you might be new, so I hope you have gone to the Proctor track and onboarded yourself and made sure your machines are all set up for the exam and all that. If you haven't done it, please do so urgently. Don't wait till the last minute. Get any issues resolved from Proctor Track help so that you are all set for doing the exam. The exam will be released tomorrow at 9, Friday, 9 a.m. EST, and will remain open till Tuesday, 9 a.m. EST. Again, as we announced earlier, the duration is 3 hours and 15 minutes, but the real duration is 2 hours, um, 45 minutes. So you should have plenty of time. In case you get into any problems, please make sure that you contact Proctor Track. And most cases, you should be able to restart right away at the place where you had the problem. The work is saved. Most of the time, make sure you keep saving it too as you answer the question, and talk to Proctor Track, and they will tell you whether you can just restart where you left off. Sometimes, in a very, very rare case, your work is not saved, and then Proctor Track will inform you about it, and you inform us immediately, and we'll set up a retake of the exam. But that's almost never happens. So mostly you should be just fine. Work with them in case. Don't panic, because sometimes the videos can overwhelm your system and things can crash and so on. But don't panic even if this happens. Talk to the Proctor Track help, which is live, and get back on track. We are, of course, allowing extra time. And in case of any glitches or any real problems where your work is lost and things like that, please talk to Proctor Track and also tell us. We'll discuss it with Proctor Track and make sure that you are not unnecessarily penalized. We'll give you the exam again if we need to. um, Again, the exam is comprehensive, covering all the topics because we didn't have any exam in this class. So make sure you don't leave out any topics right from the beginning till all the way till the end. Um, Read things thoroughly, understand the concepts, and do the needful. Um, your project too will be graded a little later because the TAs have their own exams, as you can imagine, and so you'll get those scores next week. Other than that, I think it had been a fun semester. I hope you really learned this very interesting topic, which is very, very important. And there are lots of course, opportunities in this topic in terms of jobs and further studies and whatnot. And this should help you strengthen your concepts and system skills. And I hope you enjoyed it. I would really like to thank both TAs, Chao as well as Yuhong. They worked extremely hard and done all the support for running the projects, answering your questions, grading, and whatnot. And they are the pillars of this class. And my sincere thanks from all of us to them. Um, they may have some announcements, so I'm going to ask them to say a few things. Ciao and Yuhong.
I don't have much to say. Just
Uh,
Yeah, I will start grading project backend this weekend, and yeah, I'll finish as soon as possible. Hopefully, I can give it back to you uh, um yeah, early next week, Monday or Tuesday.
All
Yep,
right,
that's it.
great. Thanks, guys. And uh, we should be. Uh, are there any questions on Piazza or anything that needs to be clarified last minute, or if there's anybody on the Hangout who has any questions for last minute, some concepts are not clear, we are here to answer mainly those things. So looks like nobody seems to be on the Hangout because everybody is probably studying and getting ready for the finals. Are there any questions on Piazza or any concept through the semester which you think is iffy we should talk about?
Yes, there is a few questions in Piazza. And the first question is from Daniel. He's asking why, for the project one, why we used Antler instead of Yak and Lex. What is the advantage of Antler as compared to Yak and Lex?
Okay. So Antler is sort of the modern tool which deals with many um, classes of grammars which are really sometimes have even dynamic requirements of lookups and all that. It's a professional tool used pretty much in all the compiler building. Lex and Yak were the historic tools that came with Linux. They were very useful, um, but Antler has much more powerful capabilities of generating powerful parsers, which can take advantage of dynamic lookups and a lot of. There's some background noise, I guess.
Yes.
So uh, the Antler provides you a much more sophisticated tool, which works with the modern languages. And so hopefully this experience should prepare you with writing a production style compiler. There are a lot of production compilers now being written in Antler because of this powerful way of dealing with dynamic lookups, more advanced LRK parsers, and the tree walking utilities and other stuff that come with it. So that's why we chose Antler. There are lots of grammars there for full languages which sit. So hopefully once you do this class, if you take a look at those, you will see the parsers for full Java, full C, those kinds of languages. So we hope that this familiarized you with the goal here is to expose you to some almost production level tools. Lex and Yak are a little older and they have their own place, but modern compiler writing is all in Antler. Next question.
There's another question said uh, the book and the lectures mentions instruction selection as happening before register allocation, and the naive allocation as being a part of instruction selector rather than the register allocator. Uh, why does the project 2 change that order?
Okay, good question. A very good question. So typically what happens in production compilers is that you have a mixed set, which is not entirely RISC, which is CISC oriented, which has at least some instructions which are CISC. The good example being x86, which is really a CISC oriented instruction set. So for CISC oriented instruction sets, what you want to do is combine several IR operations together as a complex instruction and then perform the register allocation. So whenever certain operations are combined, of course, you don't need to save the intermediate results in terms of register and so on. And so that's why the phase ordering for production compilers is first do instruction selection and then register allocation. The registers are, of course, useful for carrying values from one instruction to the other and certain IR operations which are a part of a complex instruction, the registers are subsumed inside. So we can't do register allocation before the instruction selection because of the complex instructions being present, CISC instructions being present. Again, the phase ordering is combine as many IR operations as possible, whatever registers are needed, then do the liveness analysis, and then find out what registers are needed to carry and reuse the results across the complex instructions. In case of our project, that is not the case. The MIPS instruction set is proper pure RISC set. There are no complex instructions there. So it makes sense first to do register allocation and then do the instruction selection because there are no subsumptions of operations inside the instructions. And so the phase ordering is decorate the IR with registers and then select the instructions, which is probably one-to-one match pretty much from the IR to the instructions. So when you're generating for RISC, in particular, a pure RISC, you will probably do the register allocation and then instruction selection. But for CISC-oriented ones, you will first convert the IR into instructions and then worry about the data flow and pick it up between those as registers through registers. So that's why the difference. Great question. Next.
Okay, the third question, still from Daniel, is asking about the simple tables. In our project, actually we use the simple tables in project 1, but not in project 2, means the backend part. But in the production compilers, they use the simple table in backend for the data layout. So he is asking how would the simple table construction in the backend could be different from the front end?
Okay, another good question. So the reason, of course, you are maintaining the symbol table as far as the backend is concerned is to decide the stack layout, the memory layout, and so on. And several optimizations really depend on it. For example, if you have 4 instructions which are reading consecutive values and you want to do the compaction of those 4 locations into one and generate a vector instruction, then you need to have that particular knowledge. You need to have the knowledge of the data types to be able to do this. If you have, of course, 32-bit data type, then you cannot do this. But if you have 16-bit data types and 64-bit operand, maybe you can combine 4 of them. So that's one of the reasons. Now, the one important thing to note here is this, that the symbol table is telling you the main use of symbol table in front end is to carry out the binding of the values to determine which value is belongs to which name. That purpose is already done as far as the front end is concerned. So we don't need some of those informations. We need more about concrete implementation types, for example, whether it's a 16-bit integer, unsigned integer versus 32-bit signed integer. That kind of information is kept as against whether it is a particular integer which can be combined with some other data type. The second difference is this, that it's a scoped symbol table that is typically kept, and the issue of scopes and all is already gone because the binding is already decided. And so we don't need some scoping and other information, which is important for resolving names in the front end. And the last piece of information that we have to be careful about is we don't need all the names to be there in the symbol table. Here is why. Most of the values in the IR are absorbed, as you can imagine, through register allocation. So in other words, no memory is ever allocated for those names on the stack. So we don't need those to be in symbol table because there is no data layout or any other issue associated with it. So we'll just keep only those which have spilled values or which we need to have a memory location for whatever reasons. Maybe it's a static and so on, which escapes the current analysis unit. So only a part of the names are there in the symbol table which have a home location. So many times this information is start with the full symbol table and you purge a lot of information. You remove the values which you don't need that information in the symbol table, and you then also get rid of some of the fields which are not relevant, such as scopes and so on. And then advanced analysis change the abstract types to concrete types in terms of the implementation, whether it's an unsigned, signed, and a 16-bit, 32-bit. Through some analysis, we determine that. And then, of course, you use it for data layout optimizations based on, what are the reference patterns in the instructions and so on. So that's sort of the big difference over there. Next question.
Okay, actually, that's two questions. Next two questions are both from Daniel and Paul is here. They're generally interested in the research directions, research trends in the field of compiler. And Paul sees some articles, papers about using machine learning on compiler optimization, and he is especially interested in these directions.
I see. First of all, welcome, Paul, to the Hangout. It's been great to see you all throughout the semester, and thanks for your questions. So I'll take up Paul's questions first and then the other one next. So yes, machine learning has been making a difference everywhere. As you can imagine, we are no exception to this rule in terms of, so where is it that machine learning is getting a lot of attention? So of course, one of the important problems is, and this is where compilers are really becoming very, very sophisticated. So as you can imagine, the machine learning such as TensorFlow and other libraries were hand optimized. But as people write newer and newer machine learning codes, which are not just in terms of libraries, but expressible in terms of domain-specific languages. For example, somebody is coming up with their own machine learning model, expressing it, compiling it. So there is a movement towards that, rather than trying to just rely on some TensorFlow and some fixed libraries. So compiling for speeding up machine learning is one very, very important direction. And as you can imagine, machine learning does take a lot of time, especially during training. It takes so much time to converge, and it can really be very expensive in terms of time. There is a especially moment to generate the IR, which allows you to do the machine learning languages for learning languages to come out and to really optimize the code for machine learning algorithms. So especially parallelism side of it is very important. As you can imagine, GPUs and other, that's where most of the ML algorithms get implemented. So idea is this, that maybe start with a CUDA kind of a language and have some machine learning annotations to it, and then use that to compile it into a very efficient GPU code. So there's a new IR being proposed in LLVM, which can take the higher level languages, convert them into LLVM IR with some annotations for machine learning, and then to take this all the way down to CUDA and to the GPU code, PTX, and so on. So this is one very important direction. There have also been efforts in using machine learning to do better hard analysis, solve hard analysis problems, especially that has been used in bug finding in some situations. There were papers in NIPS kind of conferences to find, for example, what is invariant in this particular program. It has been very difficult to construct that. So the ML algorithms were able to suggest those invariants and likely invariants rather, and then they were checked using some model checking or verification software so that we know the correctness of the code. So there have been use of machine learning also in proving verifications and proving correctness and solving some hard analysis problems. So these are the two different things that are going on. The conferences I would recommend is PLDI. You can note that P as in Paul, L as in Lambda, D as in David, and I as in India. And the second one is NIPS, NIPS. There have been few papers. NIPS is a machine learning conference. PLDI is the compiler or program analysis conference. So that's what is going on. And what was the second question?
The second question? No,
Yeah.
actually, Daniel is just asking some general trends in the for the research.
I see. So yeah, I think one of the biggest trends is machine learning. So I already covered that. The second one is a lot of interesting work on parallelism and its management. We are getting now quantum and all these kind of new models coming out, which actually have massive amount of parallelism, and there are some new languages coming for quantum computing, and compilers have to get ready for these new architectures which are based on quantum, and the code generation and everything else will change. So IR onwards, everything will have to be rethought for these languages. And so that's another interesting, exciting, as newer and newer models of computation come through, especially quantum, which is very different. We had to rethink the whole backend. That is another one. And I guess ML and that, I think those would be my top picks. There are many things going on, but they always keep happening. Newer IoT-oriented processors come in. There are lots of languages being proposed which are domain-specific, especially which provide data annotations for privacy and what you can do with data and so on. Because data, there are lots of restrictions on data. So when you write some program, how do you enforce those? How do you not leak the data? How do you not allow some invalid operations on it? So you express these through a policy on the data, and then the policy and the data is compiled with certain checks for privacy, for not sending the data around, for not illegally combining it, and so on. So that is another interesting place where lots of domain-specific annotations and languages are coming, and how to efficiently compile them is an issue too. Nice questions. Thanks, guys. Paul, you're here on the Hangout, so you have any last-minute question or anything to add?
Yes, I just want to add something very small concerning what you just said about quantum computing. I think in future, as quantum computing becomes mainstream, we'll find maybe a similar fad like machine learning, like the way we're having machine learning today. And maybe at that time, perhaps there'll be a more renewed interest in compilers, especially compilers for quantum computing. That's how I see things.
Yeah, that's correct. I think the as so the fundamental problems have to be solved in some ways to gear up for um, some disruptive technologies, but these problems are more important and will take some time to really get solved. So I think compiling technology will see some very interesting refresh. And the uses of these are tremendous, but the enablers are the hardware and, of course, the software, which basically means compilers. And so, unless the hardware is being worked on for a while, and they have made some progress there in nanotubes and all that, but software is just about to start, and unless that is done, there is no hope there. So, this is a time to nicely think about interesting possibilities there and try and grapple with them. And of course, there are these technologies will take time to come out in full form, but there are simulators on which people are targeting the code, which mimic the machines when they will come out. Another interesting technology which has come out recently is NVRAM. So non-volatile RAM, as you know, a lot of data is kept in our DRAMs, and they don't scale beyond a particular level. So terabytes of data, for example, if you can put it in a DRAM, that will be great, but it doesn't work like that. It doesn't go beyond gigabytes. So now we have these NVRAMs, which allow you to store the data, although it's just like a persistent data, and it is available in this particular level of hierarchy, which has tremendous capacity. And so you can do a lot of data analytics at scale using local memories, and because of the terabyte kind of level of capacities. And then the real question here is, what do you keep in those memories? What do you keep in DRAMs? How do you generate code? All these interesting issues.
That sounds exciting.
Yes, it is. And Intel has recently released a machine. I guess I will forward it to Chow, and we can post it on our Piazza, which you can actually use, a real machine based on NVRAM technology.
Okay.
So, Paul, you need to visit us sometime. I hope you are able to do it.
Hopefully next year I'll pass by Atlanta.
Great. You are in OMS how long now?
Oh, this is my final year. I've done 2.5, almost 2.5. So by December I hope to finish. It'll be almost 3 years.
So December you will be graduating. Is that what you're saying?
Completing, but I'll come for commencement in May.
So that will be a good time because the weather and everything is beautiful in May. So hope to see you then, and do drop us a note.
I will.
Welcome.
Thank you so much, Chow.
And you're currently working, is it, Paul?
Yes, I am.
I see. So do you expect maybe after OMS to go in a different career path or continue or?
I'm still in a dilemma whether I should actually do maybe a second master's like the OMS cybersecurity, which sounds exciting, or do a PhD. So you can say I'm playing around with Schrödinger's cat on that.
I see. You can do both by doing a PhD in program analysis for security. So, and when you come down here, we can talk about it. If you
Okay.
we are doing a lot of work on applying compile analysis towards security, just to tell you. And a lot of hard problems in security is being solved through ML. That's all I can say right now. But we'll be happy to discuss this one-on-one with you.
Okay.
If you have some interest even after the exam, and if you want to do it remotely, that's fine too, to discuss it. And then hopefully that will help you to make some decisions of whether to. I would suggest PhD and not doing a second master's. You can always do some classes during PhD and also do something interesting.
Okay.
Of course, it's a commitment for about 5 years.
After the masters, I thought it would be maybe 4 years because you'll get some credit.
Yeah, you do get, but the work itself takes time.
Oh, okay.
Yeah, 5 years is reasonable. I think sometimes little even more, but 4 years is a little shorter time span because it takes time to really get into the area, understand things, get some maturity there. So that some preparation is needed there.
Oh, all right. And how competitive is it to get into a PhD? I read somewhere you need 3.5 GPA and above.
Yeah, so it's a combination of things. The letters that you can get, the GPA, what research interests you have, whether you have done something already before you enter the program. It does help to do a little bit of research and get involved and test the waters, so to say, so that you also have a good idea.
Okay.
PhD is slightly different than masters, right? It's like going into a little bit of unknown in terms of a problem, and there's a bit of uncertainty there. But yeah, it takes so all this matters. I'm sure your GPA and all shouldn't be any problem. I mean, and there are some OMS students who have joined with me. One particular student who did the class with me 3 years back, he is my current PhD student finishing first year. So there is some good trend here from especially OMS students to do PhD.
Okay. And is it fully funded or you have to also support yourself,
No,
self-funding?
no. So it is fully funded and it's guaranteed through the whole program.
Oh, okay.
So yeah, you can't be working and doing PhD at the same time. It's a distraction.
Oh, yes, it is.
So yeah, it's good to know you're thinking along some of those lines. So
Yes, I am. And I hope I succeed in first of all, I want to just finish the masters and I'll think about that and prepare myself.
yeah, definitely. I mean, I think now towards the end of the masters, you probably have a good idea of your interests, and then think from there. And our application deadlines for fall, so we admit only in fall. Okay, we don't admit year round. And
it's 22 hours.
Sorry about that.
right, no problem. So our deadlines are typically November.
Okay.
For the next fall.
Okay. So basically, maybe not this year. Perhaps I'll consider 2020, November 2020 going, perhaps.
You can apply this year too, if you want to. I mean, of course, if you need more time to make a decision. But I would suggest this, that you can discuss it with some other PhD students, generally have an idea of what all it takes and what kind of lifestyle is that and what is the future after that. So you can generally take, because things won't change between now and it will put a delay of maybe a substantial delay. So it's, see, if you're graduating in this December, 6 months you can do something and prepare yourself, and then in fall you can join. That's a good calendar, but adding one more year, it's a little bit of might put a delay. So just a suggestion, but it's up to you.
If you need help, you can talk to me. Maybe.
Exactly. And you can also talk with Yu Hong, who is also thinking to join for PhD.
Actually, my personal suggestion is if you want to do the PhD, you should do it as soon as possible.
Exactly. Because again, it changes like your lifestyle. If you're a PhD student, you're a student, you have to work late nights. And then you have to meet deadlines, you have to push yourself sometimes 24/7. for like, ask Chao about all this. We said we did all this.
Professor, I have to leave earlier. I
Yes.
need to practice for my presentation.
Sure. Good luck
Okay.
on that. Okay.
Okay, thank you. Bye.
Right.
Okay.
Okay,
Bye.
so we'll also probably should wrap up unless there are any other questions or any other thing that we need to visit. But other than that, good luck to everybody for the finals. Hope things go well. One last request from our side: please do fill up the CIOS survey. It really helps us to find out where we should improve, what you liked about the class, what you think we should improve, and hope you all had a great learning experience. We enjoyed, and I want to thank again the TAs who were the real deal in this class, who helped me, and hope it adds to your learning experience. Please let us know your opinions. Please do keep it up before you all get busy and with your other things during summer. And good luck for this exam and for something else that you might have. And we will, as far as PIASA is concerned, because the exam will be in progress, so we will not be able to answer questions because during the exam, some students would have taken the exam, some others would be in the middle of taking it. So it may not be fair. So as a policy, if you have any further questions about clarifying anything about some difficulties, please send us to us by today evening. By tonight, after tonight, we'll stop answering PIASA during the exam duration, and then we might clarify some of the questions after the exam is over. So it's like this, that during the exam, somebody raises a hand and asks the question, hey, please explain me this. So that may not be the right way to do it. So that's why this policy. And again, good luck, and hope to see some of you in person, and all the best.
Thank you.
Good luck.
Thank you.
So Chao, you can terminate.
Okay, see you.
See you. So see you in a bit. Okay.
Okay,
Bye. Yeah.
bye.